Hello, dear students. Today we have Proposition 9 of Book 2. Proposition 9, Book 2. If there be a line and it be cut into equal and unequal parts, the rectangle, the squares on the unequal parts together, one plus the other on the unequal parts, will be equal to double the square on the half and the square on the line between the points of section. Okay, and double that. Right? So here you have your line cut into equal and unequal parts, and here's your line between the points of section, between the two cuts. Okay? Let's redo it over here. You have your line. The equal parts are dotted. Okay? And the line between the points of section are this blue dotted line. Okay? The unequal parts are the blue and the red, okay? Equal, unequal, line between the points of section. Pretty cool, huh? Okay, so it's required to show that, let's see if I can get my brain working here, that the square on this and the square on this added together are equal to double the square on this, which is the half, and double the square on this, which is the line between the points of section of the two cuts. So let's make our figure. Draw from this point a line perpendicular to this line. Okay? So this is at right angles, and this is at right angles. We know we can do that. We've done it in the previous prop. On a line, point on it, draw a line perpendicular. And then cut from the greater a line equal to the lesser. These are equal to each other. Let's cut from this, so it's equal to this and equal to this. Now let's connect the 2 points, and might as well connect this with red. Let's just keep using blue. Okay, connect these 2 points. Great. Now at the point of cut, let's draw a line parallel to this. Okay. From this point of cutting, let's draw a line parallel to this, given a point not on a line, to draw a line parallel to a given line, just like we did here and here. And these 2 points, let's connect with this line. Great. Okay, now remember, this is equal to this and this, because these two are equal. Great. So here you have a right angle triangle. Let's look at this triangle, and it's right angle. And this is equal to this, so the angles at the base are equal. Okay? We're going to just keep doing that all over the place, and we'll come back. Likewise here, the angles at the base are equal, because this is equal to this. Okay? Now look at this. This is a right angle, and the interior angles of a right angle are equal to 2 right angles. This is equal to this. This plus this are equal to 2 right angles. This is a right angle, so this and this are 1 right angle, and they're equal to each other, so each is half of a right angle. Likewise here, each is half of a right angle. And so half of a right angle plus half of a right angle, that gives you a whole right angle, okay? Now, we know that this is right angle because you have 2 parallel lines with a line falling upon them, creating an outside angle equal to the interior and opposite angle. But the interior and opposite angle is right, so therefore that's right. Okay? And this triangle, 1, 2, 3 angles equal to 2 right angles. This is right. This is half a right, so this is going to be half a right. Half a right plus half a right plus half a right equals 2 rights. Great. And here you have a line, 2 lines, straight line falling upon them, creating an alternate angle equal to the interior, outside angle equal to the interior and opposite angle, so they're equal. But this is half a right angle, and this is half a right angle, and this is half right angle, so you have a triangle with angles at the base equal, so this is equal to this. In this triangle, this is equal to this. Likewise, in this triangle, the angles at the base are equal, so this is equal to this. Great, we needed to do all that for later, okay? So what else? And let's remember that this is a straight line, 2 straight lines with a straight line falling upon them. The outside angle is going to be equal to the opposite and interior angle. So this is right, and this is equal to it, so this is right. Great. So we'll get going on the proposition here, but look, this is a right angle, this is a triangle with a right angle, this is a triangle with a right angle, and this is a triangle with a right angle. And you guessed it, we're going to use proposition 47 all over the place, okay? So let's look at this triangle, a right angle triangle, with these two sides being equal, okay? Here's the hypotenuse of the right angle. So the square on the hypotenuse is equal to the squares on the sides added together. But those two squares are equal because they're on equal straight lines, okay? These are equal. Let's go like this. And great. So if the square on this is equal to the square on this and the square on this, and the square on this is equal to the square on this, you could also say that the square on this is equal to double the square on this, because double the square on this would equal the square on this and the square on this. So the square on the hypotenuse is equal to double the square on the side, on one of the sides. Let's say this side. Great. Likewise here, remember we proved that these are a isosceles triangle, and this is a right angle. Therefore, the square on the hypotenuse is equal to the squares on the sides. And the squares on the sides are equal, therefore the squares on the sides are equal to the square, double the square on one of the sides, just like we did here. The square on this is equal to double the square on this. In this right angle triangle, isosceles triangle, the square on the hypotenuse is equal to the double the square on this. But this line is equal to this line because they're opposite sides of a parallelogram. Therefore, if the square on this is equal to the double square on this, and this is equal to this line, the square on this is equal to the double square on this. Great. So, what do we have here? We got the square on this equal to the double square on this, and the square on this equal to the double square on this. But look at this triangle, and it's a right angle triangle. Therefore, the square on the hypotenuse is equal to the squares on the sides. But remember, the square on this side was equal to double the square on this, and the square on this side of this triangle is equal to double square on this. Well, the square on this and the square on this are equal to double square on this and double square on this, and also equal to the square on this because it's the hypotenuse of the right angle triangle. It must be the case two things equal the same thing equal to each other. These two squares equal to double these squares, and these two squares equal to equal this square on this. The square on this line must be equal to double the square on this plus double the square on this. Okay? Well, look at the square on this line now. In this triangle. Ha! Another right angle triangle. Because these perpendicular, a line falling upon a straight line creates either two right angles or adjacent angles equal to two right angles or two right angles. That's a right angle, therefore that's a right angle. So here, this is a right angle triangle. And we know in a right angle triangle, the square on the hypotenuse is equal to the squares on the sides. Okay? So the square on this is equal to the square on this and the square on this. But the square on this is also equal to double the square on this and double the square on this. Two things equal the same thing or equal to each other. So since double square on this and double square on this equal to the square on this, and the square on this equal to, and the square on this are equal to the square on this, double the square on this and double the square on this are equal to the square on this and the square on this. Okay? So double the square on this and double the square on that are equal to the square on this and the square on this. But this is equal to this. So the square on this is equal to the square on this. So double the square on this, two things equal the same thing equal to each other. Double the square on this and double the square on this are equal to the square on this and the square on this. Great. But the square on this and the square on this are the squares on the unequal segments. And double the square on this is double the square on the half. And the square on this is double the square on the line between the points of section. That's where they were cut, these two parts. Therefore, we have shown that if a straight line be cut into equal and unequal parts, the squares on the unequal parts added together will be equal to double the square on the half plus double the square on the line between the points of section. Very cool. Let me say that one more time, universally. If a line be cut into equal and unequal parts, the squares on the unequal parts will be equal to double the squares on the half and double the square on the line between the points of section. Quod erat demonstrandum. Remember, it's about lines. We just proved something about this line that was cut into equal and unequal parts. That the squares on the unequal parts will be equal to double the square on the half plus double the square on the line between the points of section. Thank you. Bye-bye.